The full wave rectifier produces output peaks for both cycles. All the peaks are positive. Consider this circuit. This is one implementation of a full wave rectifier. The secondary winding of the transformer is center tapped. Hence, two equal voltages are provided to each half. Now, when the input line voltage on the primary side is positive, both halves will be positive with polarity as indicated. D1 will conduct and D2 will be reverse biased. Notice where the anodes and cathodes are. The current will flow from D1 through R this way and back to the center tap of the transformer. The output will be like this, where Vd is the voltage drop across D1. In the negative cycle, both voltages labeled Vs will be negative. D1 will be reverse biased and D2 will conduct. Notice the reverse polarity on the voltages. The current will be conducted through D2 and R in this direction, then back to the center tap. Notice that current flows in one direction in R. This is why the voltage is unipolar. It is always positive despite the line voltage being alternating. The transfer characteristic of the negative half is like this, and the complete waveform is like this. This ability to produce a unipolar signal in every half cycle is what makes the full wave rectifier preferable to a half wave one whenever rectification is needed. Coming back to multisim, here we have the input voltage, the center tap transformer, the diodes, the resistor and the oscilloscope. However, let's click on the transformer. Notice here that the number of turns for the primary and secondary are equal. If this is not the case, your output will not come out properly. So let's play that. We have at terminal A the output across the resistor R1, and we have at terminal B the input signal V1. Here you can see that the orange graph is the rectified output and its amplitude is slightly less than the input signal, which is in red. This is exactly the output we have in our lecture. Now, to calculate the peak inverse voltage, consider D2 in positive half cycle. Cathode of D2 here has voltage of V0, while the anode here has voltage minus Vs. Agreed? The reverse voltage across the diode, cathode minus anode, will be V0 plus Vs. It will have a maximum value of Vs minus Vd plus Vs. Check the graph. The highest value of V0 indeed is Vs minus Vd. So PIV equals 2Vs minus Vd.